I'm Fabrizio. First of all, thanks for the invitation and good afternoon to everyone. I'm the coordinator of the project HORSE, and the acronym means Holistic, Omnipresent, Resilient Services for Future 6G Wireless and Computing Ecosystems. Here there is just a little bit of information for you about which is the call and which is the size of our project. So basically, we are targeting the issue of providing and studying the 6G infrastructure in order to provide the correct balance between connectivity, computing, and security. And to do that, we try to have a holistic vision, so to try to start back from the basics and a global look at the system and trying to combine the recent advancement in research on the different topics to identify the right position in the overall architecture. This is the European dimension, so those are the partners in HORSE. Some of them are also present today here in the meeting. So in general, we are focusing on 5 challenges. I will not go too much into details, but just to give you an overview, the main one is to look at this holistic vision to understand how the evolution might lead to 6G and how maybe 6G might evolve in the future. And to do that, we focus on some aspects, one is the orchestration, to be sure that we are able to provide end-to-end secure orchestration solutions. Another one is to address, of course, security, because we are in the security call, both from a human-centric approach and from an automated approach, trying to take the best of both. And especially we are interested in understanding how we can predict failures and especially attacks, because we believe that systems are evolving very fast today, and probably with the introduction of AI and softwareization, this evolution will become much faster. And for this reason, security will remain an open problem because of this dynamicity. So it's difficult to follow up and be always sure that everything is properly secured. And for this reason, we want also a system that is capable of self-evolving in an autonomous manner in such a way that it can predict even potential threats and find solutions ahead of time. Just one point about our way to work, because it might be interesting. We are in the process already of developing the first release of the HORSE architecture. Today we are currently in month 13, as are the other projects, and we are starting to finalize the deployment and the deployment of the modules of the architecture in the first release. So by June we will have a first view of the architecture. So if you are interested in getting feedback from what I present today about actual performance, I will be able to come back relatively soon. This is the functional architecture that we are targeting. We are working on top of the infrastructure, so we don't address directly infrastructure-related issues. Regardless, we assume that we have the capability to interface with the RAN, with the core, and the other components of the infrastructure through specific connectors. What we are building is, starting from the bottom, an AI secure and trustable orchestrator that will be able to provide end-to-end security. On top of that, we want to deploy a layer of platform intelligence that basically will enable to have AI reasoning, but also to be able to provide a sandbox where we implement digital twins to predict and test what-if scenarios, and also have components related to controlling policy and data governance in the most appropriate manner. Finally, on top of everything, we have an intent-based interface that is used both to understand the intents of services and the intents, for example, of potential threat mitigation techniques provided by the AI, but also to include intent-based strategies provided by the users. The overall structure work like this, just to show you in general a potential sort of workflow. So basically we are continuously analyzing the data that we get from the infrastructure, and this data is fed both to the real context analysis modules that work on the actual data and try to detect and mitigate the current threats, but also this is mirrored by a sandbox where the same data is used to build the sandbox where we have digital twins that are capable of predicting and preventing, so like a mirror of what is happening in the real context, but also to perform impact analysis, so we can study what-if scenarios. The idea is that both from the real context or as well as from the sandbox, we can get advices to the AI engine that here we call the DTE, that will analyze the indications and it will identify, for example, whether there is an actual problem, or it will decide whether the attack that is detected is dangerous, and it will speak with the intent-based interface in order to identify what to do. However, this decision will be mitigated by the policy configurator to understand whether the decision makes sense, but also by another interaction with the sandbox that can be done to analyze what-if scenarios, so to have a precise evaluation and prediction of what might be the impact of our decision themselves. This is mostly the idea, and of course we have then the action. So we have the reliability, trust, and resilience provisioning module that will implement the security decisions by sending actions to the connectivity manager, that is the end-to-end orchestrator in this case. The rest of the presentation, I try to structure it based on the questions that Mauro proposed as I was invited to the meeting. What we believe are the 6G enablers that can be inherited or can be learned by the HORSE project. We have three main points. On one side, we are studying secure orchestration. Another enabler will be the intent-based component, but we believe that probably the most interesting one is the network digital twins for prediction, but also for analysis of what-if scenarios. And the reason for this is that based on a previous deliverable, when you presented the service management and orchestration functionalities that you predict in 6G, we believe that the network digital twin might represent a set of AI ML functions that can be put in the network layer management and orchestrator component of 6G. So I will spend a little bit more time describing what we are doing in the digital twinning, but of course I'm available also to discuss about the other points. We believe that to use the digital twin is for sure an interesting technology to integrate it in the AI infrastructure. And this happens for two reasons. One is that, as I already said maybe a few times, we can have the capability on one side to make an analysis of the network status, because the digital twin is a perfect copy, let's say, of the original, or let's say a very well approximate version. So we can detect anomalies, we can detect and prevent security threats, and also we can go in the future or in the past. So we can use it in the sandbox to analyze hypotheses or what-if scenarios. This is more related to decision making, but there is also another important aspect where we believe the digital twin maybe will be even more important. That is the fact that we can use the digital twin to generate realistic data that we can use to train AI and machine learning, because one of the problems that several machine learning approaches have especially is that they needed to be able to understand the result of their actions. So they need to know whether they took a decision and that decision was true or not, it was good or not for the system, for example. And to do it in a real infrastructure, of course, is dangerous. Or on the other side, it might require to use a fixed data set. With the digital twin, we can use the same component and spawn another digital twin that can be used for generating data set. So this will facilitate the generation of potential even training set for AI. For example, we can try to invent a new attack and see what might be the impact, and this can be used to help AI to better protect the system. The position of this module here is in the orange part, sorry. We believe that it's worth it to have at least a couple of versions of digital twin. One is that it's more continuously reconnected to the real context, which is a tightly coupled digital twin that can be used for prediction and prevention. And another one is to have a digital twin most appropriate for what-if scenarios, and maybe even be able to go beyond what we have as a real twin. So another digital twin that can go, let's say, beyond the physical reality of the system. And those are called prediction, prevention, and impact analysis digital twins. This is a little bit how we think we can build the digital twin. So we need a module that automatically generates and replicates the topology, the services, and the traffic that is recorded from the actual twin, and it can generate a forecast, for example, of the traffic. This will be used to trigger the digital twin engine that will generate one, let's say, instance of the digital twin. Here you can see two, for example, 1 and 2, that can run in parallel and address different predictions. Then we will have a sort of AI machine learning component that will be the prediction module that will be used to derive information and to understand whether it is important to signal the other components. Similar for the impact analysis. Here is one example, let's say, of how we can use this approach. The idea is we get the measurements from the infrastructure. Those go to the smart monitoring and pre-processing modules that generate the data lake that we use for triggering the data to the sandbox. You can see it in the middle of the diagram. In the sandbox, we can run threat prediction. So we can understand whether we believe a threat is incumbent or it's happening. And then based on that, we can alert the AI module to trigger maybe an intent and analyze some potential scenarios to fix the problem. Those will come back to the sandbox in terms of what-if scenarios, and we will run them, even more than one in parallel, to understand the actual impact that will be provided to both the AI and the intent-based interface. Then, based on that, we will be able to take a decision. Then everything, of course, we will continue the cycle, and finally, we will select the best potential actions based on what the sandbox provided as a potential feedback from the system. About the question, what are the assumptions about support or means from the end-to-end system for that enable to work? At the moment, we believe that it's not fully available a set of interfaces that can allow us a continuous synchronization between the physical and the digital twin, because we need information not only from the infrastructure, but also from the orchestrators. We need information even from the services and so on. Probably we will need to define, that is what we are doing in the project, a set of features that we need from the physical twin to build an accurate digital twin. And also the problem that we have now is that 6G is not yet there. So we need to invent or to build our own 6G infrastructure so that we can mirror it as a digital twin. In our case, of course, it would be a 5G network with some extensions somehow. What we propose to implement in this case is to have a sandboxing component that is continuously fed with status information from the network, and this is used in order to build one or more digital twins instances. One important aspect is that we strongly believe that digital twins should be emulators and not simulators, because it is important, especially for security, to be capable of on one side, running in an isolation mode so that we don't affect the rest of the system, but also to be able to deploy real systems, real modules, real security approaches, in order also to be able of analyzing potential threats, for example, because of the SDN or NFV infrastructure that we use in the real system. That are things that typically in a simulator it's difficult to have in a clear representation. And the other thing is we believe that with the digital twins, we can have an interesting way, because to represent also the state of the system and to have a movie that we can play back and forward in time. And this links to the fact that we can train system, but also we can use it to predict the future. So those are the principles that we are using to develop our system. And we believe that in the 6G infrastructure, this might represent the sandbox, might represent a network function or a set of network functions that in the original deliverable were indicated as AI machine learning function. In our case, we are working mostly on security. so security from attacks like denial of service, but also inherent security of the infrastructure, for example, like security of the user plane function or security of the system that supports the user plane function. But also, of course, this concept of the digital twin can be extended also to analyze the performance or to understand which might be new setups of the system to improve in some cases of failure. In our case, we use an emulator. That is what we will demonstrate. We will actually build two kinds of digital twins. One will be based on Kubernetes environment that will enable higher scalability. And one will be a smaller one that is the one that here is presented, which will be to use Mininet, if you know the environment, with network function virtualization so that we can deploy real systems, so a real 5G core, a 5G RAN, 5G RAN maybe emulated in the case of the wireless medium, but to be as accurate as possible. So we can really test even software components for weakness, bugs or points of weakness on our system so that we can actually go not only in, let's say, traditional attacks, but more also software-oriented attacks. For example, we are building a system like this, merging a UERAN SIM, that is a well-known 5G RAN emulator, with the Open 5GS, which is another relevant component. But we can do it with different things. The approach is that everything that can be containerized can also be deployed in the digital twin. So we can even deploy actual services if we want. So we can go higher in the layers of that stack. We can deploy, of course, firewalls and any other network component that can be virtualized. Just to go to the KPIs, we can consider the digital twin sandbox as a 6G enabler that is focused on one of the system requirements of 6G, which is security, of course. And specifically in our project, we have a few KPIs that are related to this that are mentioned here. We promised in the technical annex to develop and validate AI-assisted threat detector and mitigation engine, but also AI-assisted models to prevent physical and, of course, also higher layers attacks. Finally, as a last point, there was also a point of discussion about standardization. And here are a few contributions that, as a consortium, we already achieved. We contributed to the ETSI Exponential Networking Intelligence Working Group, and especially in the document GR035, where we discussed about and we achieved to introduce the idea of the digital twinning as a strategy for increasing the level of autonomicity of the system, so that there are some layers of advanced autonomicity that are triggered by the usage of digital twin that we believe will be useful, of course, to integrate in 6G. And also we got approved some documents in the Internet Research Task Force on the application of AI to network management that are related still to digital twinning and AI application. But we are also active at the moment in both in ETSI and 3GPP. So in ETSI, we are working in ETI, ENI, SAI, and Zero Touch. In 3GPP, we are working with SA3. And of course, we continue to work with the Internet Engineering and Internet Research Task Force to bring our ideas and discuss our ideas in standardization. With this, I thank you for the attention. I'm available for questions, even in the chat, if necessary.
Yes.
Thank you.
There's one question in the chat. So in this horse architecture that was shown, are domains considered to be also under different administration, for instance, be part of different providers' infrastructure that require isolation from other providers?
We didn't focus so much on that. Let me go back in the presentation. So the question was about the infrastructure. What we assume at the moment is that we have access to not a single owner infrastructure, but we have access to the infrastructure to these orchestrator connectors. The level of interaction and of isolation of the sections of the infrastructure depends on what these connectors will enable. So we leave, let's say, to the owners of the infrastructure to export their capabilities in a similar way as an EF, but also to decide what we can control of the infrastructure.
Okay, thank you very much.